Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GMAT out of this book here, the GMAT review, the official guide. If you do not own this book already, purchase one immediately. You'll be able to find it at mba.com. The problem that I'm about to solve is the one that you will find on page number 180, problem solving number 207. Let's take a look at it. It says if n equals 4 times p, alright, n equals 4 times p, and p is a prime number greater than 2, alright, so p is a prime number greater than 2. And if you do not know what a prime number is, go through the solution, go through this book here in all the previous questions, 1 through whatever it is, 206. Go through all those problems, and that's what you have to do if you want a decent score. You have to do the work. Go through those problems, find the problems that deal with the prime numbers. I think there are like 3 or 4 problems in this thing that I've already done which deal with the prime numbers. Watch those clips and you will learn what those prime numbers are, because right now I don't want to go through the details of what a prime number is. A prime number is basically something that goes into itself, n1, and nothing else. So 2 is a prime number because only number that 2 will divide into is itself, n1, and nothing else. 2 does not go into anything else. 2 is a prime number, so is 3. 3, the only number that 3 will go into is itself, n1, nothing else. 5 is a prime number, 7 is a prime number. What about 9? 9 is not a prime number because 9, in addition to going in itself and 1, any number will go into itself and 1. That's just a theoretical curiosity. Question is, does it go into any other number besides itself and 1? The answer is yes. 9 will go into 3. 9 will go into 3 very nicely, evenly. So it's not a prime number. These are prime numbers. 11 is a prime number. 13 is a prime number. 15 is not a prime number because 15 will go into 3 and 5, so it's not, and so on and so forth. So we have n, we are told, which equals 4 times p. We are told that p is a prime number more than 2. So far so good. The question simply is how many different positive even divisors? Oh, that's a mouthful. So we're looking for, well, I'm going to write down some positive different. They have to be positive, they have to be different. What else? There are 3 conditions. How many different positive even divisors? Even divisors. And you don't know, if you don't know what a divisor is, I'll explain to you in a second. But it's very important that you pay attention to the wordings, because that's what counts. You have to read the words are there for a reason. They're looking for, they have to be different, they have to be positive, and they have to be even divisors. So let's take a look at it. I'm going to plug in something for p. Since we are told that p is a prime number more than 2, let's start with 3. So let's pretend that p is 3. If p were 3, this would be 12. The question is, how many different divisors are there? Different positive even divisors. Divisor means factors. What are the factors of 12? Let's find out the factors of 12. If I have 12 here, 12 goes into 2, that's 6, that's 3, and that's about it. And then 3, and then of course 1. So I'm going to make a list now. So it looks like 12 goes into 2. It will go nicely into 2. These are divisors. It will also go into 4. 2 times 2, 4. It will also go into 2 times 3. It will go into 3. It will go into 2 times 3, which is 6. And of course it will go into 1. And it will go into itself. I should have written it more systematically. Let's put the 1 in the front. I should have started out with 1. Because of course any number goes into 1. And any number will go into itself. So these are the divisors. See this part here, divisors. But the conditions that we have to fulfill here is they have to be positive, they're all positive. I didn't bother with any negative ones. They have to be different, which means I cannot count this 2 and this 2 twice. They have to be different. And the last condition is that they have to be even. So that rules out 1, that rules out 3, and that's it. So how many do you see? I see a 2. 2 is a divisor of 12. I see a 4. I see 6. and I see 12. So it looks like the answer is 4. There are four positive different even divisors of 12. The divisors are 2, 4, 6 and 12. The answer is 4. The answer is C. There are 4 divisors right here. Where should I put it? Let's put it at the bottom here. The answer is C. Now if you want to convince yourself that this does actually work, try one more time. I'm going to do a different one now this time. This time I'm going to do something different. I'm going to leave the 12 alone. Let's try something else. Let's put in 5. Because 5 is the next one, let's put in 5 here. So now I have 20. Let's see what kind of divisors we'd find for 20. I'm going to do it on this side here. Let's find the factors of 20. Of course, 1, 2, 5. There we go. So let's find out all the divisors, okay? So it looks to me that 20 will go into 2. It should also go into 2 times 2, which is 4. It should also go into 5. It should also go into 2 times 5, which is 10. And of course it goes into itself. And of course it will go into 1. So these are the divisors of 20. Another way of saying divisors is factors. Divisors, which is same as factors. These are the factors of 20. Now we are looking for positive, which they all are. They have to be different. They're all different. But they also have to be even, which means I can rule out, I cannot count 1, I cannot count 5, and there you go, you have only 4 left. 1, 2, 3, and 4. There are only 4. Answer does not change. The answer is C. There are 4 divisors. Let me take a look at the clock at the back. And that was it. If you like, you can try it again yourself. Put in 7 here, it will not change the thing. You will still find 4 divisors. If you have 7, it will be 28. If I put in 7 here, we'll have 28, and 28 will give us 28 will give us, oh boy, 28 will give us, there you see. So the positive, different, even divisors are going to be 2, 4, 14, and what else am I missing? And of course the 28 itself, there you go. I forgot the 28 itself. There I see 4 positive even divisors. That's all. So the answer does not change, the answer is C. I hope you found this helpful, and that's the way to do it here. Don't do it in any theoretical work. Just plug in numbers. And of course in the real exam I wouldn't have tried it 3rd time. So I would just do 2 of them. If the answer is the same, the answer is C. It doesn't take that long to do it out. I hope you found it helpful. If you wish to buy my DVDs in which I show you the solutions to all the problems, or if you wish to hire me for personal private tutoring, face-to-face tutoring, I'm located in Connecticut. I'm also in the process of putting together a solutions manual in the form of a book of all the problems. There are 400 problems in this book, 250 problem solving, 150 data sufficiencies. As I said, I'm in the process of putting together a solution manual in the form of a book. Hopefully it will be done soon, a month or so maybe. In any of those scenarios, if you wish to get hold of me, go to my website at www.prep.gmat.com and get hold of me. Alright? Thank you. Send me an email and we'll talk. Thank you.